We're back with section 10.3 part 2, where we're going to begin to explore more complex and robust problems around simplifying and multiplying radical expressions. So we're going to begin by taking a look at question 47. And in this problem we're going to have the square root of a to the 6th and b to the 7th. And we're going to try to do is simplify this as much as we can. So remember, so I would write this down as is, but one thing that may be helpful is we're looking at a square root. So what we want to do is we want to get even exponents, because we know when we write these with as a rational exponent, we want numbers that divide evenly. So what I'm going to go ahead is I'm going to divide or rewrite this as a square root of a to the 6th. That's fine. But I'm going to take b to the 7th and then write it as b to the 6th times b. So what will happen now is I'm going to go ahead and I'm going to rewrite this now as the square root of a to the 6th times the square root of b to the 6th times the square root of b. I know because is a square root, I can write this with a rational exponent as a to the 6th divided by 2. For b to the 6th, I can write this as b to the 6th divided by 2. And because this is only 1, I'm not going to be able to simplify this any further, so that's going to remain the square root of b. Well, a to the 6th divided by 2, that's a to the 3rd. B to the 6th divided by 2 is b to the 3rd. And then it's going to be just the square root of b. And this is my final answer in simplified form. So all I'm looking to do is to take some large quantities under the radical and try to simplify them as much as I can. This is how it applies for square root. Let's take a look at question number 50 to see how this applies with a third root. Same principle, but it just gets a little more complicated, especially if you're not really fluid in some of your math facts. So it's the third root of a to the 6th, b to the 7th, and c to the 13th. So because it's a third root, know that when I'm writing a rational exponent, the 3 is going to be in the denominator. So I want to try to split up my a's, my b's, and my c's to be the largest possible exponent divisible by 3. So how does that happen? So, well, a to the 6th, 6 is divisible by 3, so I can leave a to the 6th as it is. Next, b to the 7th. Now, 7th isn't divisible by 3, but 6 is. So I'm going to write this as b to the 6th times b, just like I did in the previous question, except we're dealing with a third root, not a square root. C to the 13th. 13 is not divisible by 3, but I know 12 is. So I'm going to write this as c to the 12th times c. So now I have this split up into factors that I know when I write these problems separately, they're going to simplify nicely. So I'm going to go ahead and write this as the third root of a to the 6th times the third root of b to the 6th times the third root of b times the third root of c to the 12th times the third root of c. Now, do you have to do all this work here? No. This is just for your instruction. If you want to go straight from this to what I'm going to do next, you are fine to do so. Okay? So I'm going to write this as a to the 6 over 3 times b to the 6 over 3 times b to the 1 over 3, or actually I'll just go ahead and leave this as the cube root of b because I can't simplify this, times c to the 12 over 3 times the cube root of c. Well, I know that a to the 6 thirds, that's equal to a to the 2nd. I know this is going to be b to the 2nd. 12 divided by 3 is going to be c to the 12th. And here I have the third root of b times the third root of c. So I can just combine these now to the third root of b, c. Not 12. This is going to be 4 here. So a to the 2nd, b to the 2nd, c to the 4th times the cube root of bc is as simple as I can get that problem. So again, focusing on this technique here, if it's a square root, we definitely want the largest even number possible. If it's a third root, we want the largest numbers that are divisible by 3. Let's take a look at what happens in 52. In 52, we have a number we have a fifth root in this problem. So this is going to be fifth root of negative 32, a to the 7th, b to the 11th. So we have numbers and we have variables we're kind of playing this game with. Fortunately, in this particular case, negative 32 is a perfect fifth root. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. And because it's an odd root, we don't have to worry about the negative. So I can write this as negative 32. And now for the 5, I need the largest number, or largest exponent here that's divisible by 5. So I'm going to write a to the 7th as a to the 5th times a to the 2nd. And b to the 11th, I need the largest exponent that's divisible by 5, so I'm going to write this as b to the 10th times b. And this is all the fifth root here. Again, I'm going to go ahead and I'm going to split this up. So this is going to be fifth root of negative 32 times the fifth root of a to the 5th times the fifth root of a to the 2nd times the fifth root of b to the 10th times the fifth root of b. When I simplify everything here, this is going to give me a negative 2. This will give me a to the 5 over 5. This is not going to simplify, so I'm just going to leave this as the fifth root of a squared. This is going to simplify to b to the 10 over 5. And then this is going to just be the fifth root of b under the radical. So when I put everything together here, the negative 2 comes together. 5 over 5 is just 1, so that's going to be a. 10 divided by 5 is 2, it's going to be b squared. And then I have the fifth root of a squared times the fifth root of b, so it's going to be the fifth root of a squared b. And that is going to be my final answer in simplified form. So hopefully as you're doing this technique, this is beginning to make sense more and more little by little. So let's go ahead and apply to some problems where we're actually multiplying radicals, and we have to do this together. So let's take a look at a few simpler problems. Let's go ahead and take a look first at question 58. So this is going to be radical 15 times radical 5. Well, we're just going to go ahead and multiply this together. That's going to give us radical 75. Now what we have to do with 75 is we need to put this into factors that are perfect squares. If you want to use the jailbreak method, you're welcome to do so. If you want to practice that method more in class, feel free to do that. I'm going to go ahead and go right for the quick solution here. And I know that 75 I can write as 25 times 3. And I can split that up in the radical 25 times radical 3, and then that'll simplify to 5 radical 3. And so I multiply this together first under the radical, they put it under the radical, and then I break it down into different factors that I know have a perfect square. So I can take the square root of it. Let's take a look at another such problem. So if I have 62, if I have the cube root of 2 times the cube root of 4, well, just multiplying everything together will give me the cube root of 8. Well, 8 is a perfect cube. Its third root is 2. And all I need to do is to write that as 2. But these aren't going to be the sum of problems you're going to kind of see on the test. You're going to see problems that look more like 64. This is going to be 75x to the 7th times 75x to the 7th. No, I probably won't put something on this unless I want to test you in theory. Because, well, 75 times 75, well, one way I can go ahead and write this, I can write this as 75 squared. And I can write this as x to the 14th if I want to. But the reason it's nice to kind of write this as 75 squared is because if I take the square root of this, this is going to be 75 to the 2 over 2. Is x to the 14 over 2. Well, this is 75 to the 1, or just 75. 14 divided by 2 is x to the 7th. And that's all there is to that question. But most of these are usually not quite so neat, as we'll see here in a moment, coming up with 66. So in 66, we have the cube root of 7x times the cube root of 3x squared. Well, I'm going to go ahead and multiply everything together. I'll have the cube root of 21x to the third. Now, for the factors of 21, there's 7 and 3. There's nothing I can do to simplify this. But let's go ahead and write that out. The cube root of 21 times the cube root of x to the third. So as you're looking through this, you're going to realize, well, there's nothing I can do to simplify the cube root of 21, but I can simplify x to the 3 over 3 as being equal to just x. So I'm going to have x times this, or I consolidate it and make it x times the cube root of 21. And that's as simple as we can get a question like 66. Let's take a look at a few more challenging problems here, about maybe 4 to 5 questions to go before we're done with the lesson. Let's take a look now at question number 68. We have something we haven't seen before, numbers outside the radical, but something we're going to see a lot in the next section. 3 times the square root of 5a to the 7th times 2 the square root of 15a to the third. So when we see numbers on the outside of radicals, we're going to treat this separately from the radical itself. So 3 times 2, that's going to give us 6. Under the radical, 5 times 15 will be 75. a to the 7th times a to the third is going to be a to the 10th. So I keep this 6 on the outside. Let's see what else is going to come out from outside of this. So we know it's a square root, so I'm going to try to kind of divvy up everything into perfect squares as much as I can. So for the purpose of the radical, it's going to be 6 times 25 times 3, because 25 is a perfect square. And I'm going to go ahead and leave that as a to the 10th. So I'm going to take 6, I'm going to separate the 25. I'm going to separate the square root of 3. I'm going to separate a to the 10th. And now I'm going to write this all in rational exponential form. 6 times 25, or excuse me, 6 times 20, not 25, 6 times the square root of 25, which is going to be 5, times the square root of 3, which I can't do anything with. And then I can take a and write this as 10 over 2, because the exponent is 10, the root is 2. I can write this as a to the 5th. I can combine all of this together now. 6 times 5 is 30. a to the 5th times radical 3. Well, and that is as simple as we can get a question like 68. Let's take a look at a question like 70, and let's see where we go with this problem now. This one's going to be a cube root. This is going to be the cube root of x squared y to the 4th times the cube root of x squared y to the 6th. So what we're going to do is we're going to go ahead and just multiply everything together first before we begin to try to simplify this. So when I do this, this is going to be the cube root. X to the 2nd times x to the 2nd will be x to the 4th. Y to the 4th times y to the 6th will be y to the 10th. So I have the cube root of x to the 4th and y to the 10th. So what I do is I'm going to try to write x to the 4th and y to the 10th, split it up so that I get the largest exponent possible divisible by 3. So I'm going to go ahead and write this as the cube root of x to the 3rd times x times y to the 9th times y. So as I do that now, I can split that up and make that the cube root of x to the 3rd times the cube root of x times the cube root of y to the 9th times the cube root of y. Now, if you don't find it necessary to do this step anymore, you don't have to. If it helps, please continue. So this will be x to the 3 over 3 times the cube root of x, this won't simplify, times y to the 9th over 3 times the cube root of y. So x to the 3 over 3 is going to be x. y to the 9 over 3 will be y to the third. The cube root of x times the cube root of y will simply be the cube root of xy. And that's as much as you can simplify that for question 70. A few more questions before we wrap up this lesson for the evening. Taking a look now at 72. We have the third root of the quantity of a minus b, I say quantity because it's a parentheses, to the fifth times the cube root of a minus b to the seventh. Well, here I'm not going to try to multiply this out. God, don't do that. I'm just going to make this the cube root of the quantity of a minus b to the 10th. And again, like I was doing before, I'm going to try to write a minus b to the largest exponent that's divisible by 3. So I can write this as the cube root of a minus b to the 9th times a minus b. And that multiplied together would be a minus b to the 10th. Splitting that up now, I've got the cube root of a minus b to the 9th times the cube root of a minus b. As you probably figured out by now, that is not going to simplify. Hopefully you can kind of see this jump here. Well, if I have a 9 here, I have a 3 here, I can write this as a minus b to the third times the cube root of a minus b. And that is as simple as we can express that final answer there. Okay, let's go ahead and take a look now at question 74. This will be the last question for this lesson. So this is going to be the fourth root of 9x to the 7th, y to the 2nd, times the fourth root of 9x to the 2nd, y to the 9th. We're going to go ahead and multiply everything together here under the fourth root. This will be 81. This will be x to the 9th. This will be y to the 11th. And again, I'm going to try to write this with exponents that are as large as possible and divisible by 4. So I'm going to write this first. 81 is a perfect fourth root. Its root is 3 times its fourth root. X to the 8th times x. Well, the largest one will be 8 here, so this is going to be y to the 8th times y to the 3rd. So let me just go ahead and do this. The cube root of 81, that's going to be 3. Fourth root of x to the 8th is going to be x squared. Fourth root of y to the 8th is going to be y squared. But these other two things, x and y to the 3rd, are not going to come out. So we're just going to go ahead and leave them under there. And that is going to be as simple as we can get that. Take time to watch this a few times. Stop as needed. Feel free to ask questions about this in class. This work is not difficult, but it is a little tedious and it can be very tricky, especially when you're learning this at first.